Well, hi, everyone. Thank you for joining us today in our fourth and final data seminar, our data literacy seminar for March's Water Data Month. Today we have a great talk. Before we get to our presenter, I wanted to point you to the chat where I put in the playlist where you'll find all past and then future recordings of the webinars. If you happen to miss one or you want to share the talk with somebody after you've seen it and think it's particularly applicable, as well as we've been having as our kickoff month in March being Water Data Month and our kind of initiation of this data literacy seminar series, we've had a talk every Thursday of March. But moving forward, we are going to be shifting to a once a month on the fourth Thursday. So the next actual seminar in the series will be April 29th, and then after that, May 27th. And you'll see more about that if you've subscribed to the Data Digest. And you can also find information on the College of Water Informatics data events webpage, where you'll find the seminar series and other data events. Like right now, you'll see some stuff from Cal Data. They also have a data literacy learning series where they're trying to kick off a wider spread data literacy more statewide and trying to gauge interest on that. So you'll find all sorts of data stuff on the College of Water Informatics website, but this is a good calendar to kind of to subscribe to, or at least the Data Digest, where you'll find all this information on an ongoing basis. So with that, I'd like to introduce our speaker today, which is Michelle Tang. Michelle has been with the water boards for the past 8 years as an environmental scientist within the Office of Information Management Analysis. And she has worked primarily within the Surface Water Ambient Monitoring Program, or SWAMP. She specializes in web development and data visualization, as well as GIS. Her current work focuses on developing tools and resources to make the water quality data we collect more accessible and usable for all. She has completed her bachelor's degree in geography from the University of California, Berkeley, so go Bears. Today, she's going to be talking about kind of a casual intro to data visualization for the web. She's going to show a lot of the tools that she's created over her time, both in the past and in the present, and some of the tools that she's working on. So with that, I'd like to pass it off to Michelle. Thanks for joining us today, Michelle.
All right, thank you, Nick, for that introduction. I'll go ahead and bring up my presentation.
And sorry, while she's doing that, go ahead and put any questions you have in the Q&A feature, and then we'll either answer them live, or after Michelle gives her talk, we will take questions and kind of we can either have you raise your hand if you want to give your question verbally, or if we can do it in writing, that works too. And then the chat feature is actually going to be used mostly by the panelists to provide information, like the links I provided below. So just a little bit of logistics that I forgot to mention. Okay, sorry.
Yeah, no worries. Can you see my screen?
Yes.
Yes.
Okay, perfect. Thank you. All right. Thank you, everyone, for joining and watching today. I'm pretty excited about this presentation. This is different than what I normally do. A lot of my presentations are usually focused on a specific project that I've worked on or that I've helped out with. Today, I'm actually going to speak more broadly about a topic that I really enjoy and that I think isn't talked about a whole lot here at the water boards. So I hope you find it interesting, and I hope that you can also walk away today having learned something new. So the title of my presentation is A Casual Introduction to Data Visualization for the Web. It's a mouthful, but basically what I'm going to do is I'm going to talk a lot about web development. And web development isn't really, it's a big field, but I'm going to kind of narrow the focus on data visualization and how web technologies really form the core of a lot of modern data visualizations and is really kind of transforming that part of data science. So this isn't a really highly technical talk. I did prepare some code samples, which I'll kind of walk through later on in the presentation. But it's not like a tutorial. This isn't like a workshop presentation. But I do have some recommended resources kind of at the end of my slides that I can share a few later on. And then if you want to follow along, there's a link to my slides right there. It's hosted on my GitHub page, and they should be available right now. So you can just type in that into your address bar and get these slides. Okay. With that being said, let's get started. Let's kind of start with the basics. So, why is the web so important, and why do we want to use the web as a platform for sharing our findings and for sharing our data visualizations? And the first reason is pretty obvious. The web is pretty much everywhere. It's ubiquitous in our lives. We use it for work. We use it kind of for our personal interest. It's really hard to imagine modern life without access to the web. But the thing is, it's not just even that. The web is becoming even more ubiquitous due to the rise of cloud computing and also thanks to software as a service. A lot of those new ways of doing tech and those new ways of serving tech are actually becoming more web-based. And we see a lot of kind of modern solutions becoming more integrated on this single platform. So the web, in short, is a very important thing, a very important platform, and it will continue to be very important moving forward. The web is also really great because it's an open platform. There are standards that describe how you develop for the web, how you publish to the web. These are non-proprietary standards that are put forth by the World Wide Web Consortium. And they're really important because they ensure that the web is not controlled by a single company and that the web remains a freely available public resource. Because there are open standards, it makes it really easy for the web to be cross-platform. And by cross-platform, I mean that you can visit a website and no matter what device you're using, no matter what operating system you're using, and no matter what browser you're using, you're pretty much going to have the same experience across all those different devices and platforms. There are some exceptions, especially when it comes to like the browser side of things, and then also like devices due to their screen sizes. But developers today are actually supposed to take into account all those differences and serve up websites and web applications that still function cross-platform, no matter what you're using. So it's a great way to reach people without having to worry about, do they have the right software installed? Do they have the right plugins installed, and all of that kind of messy stuff that makes things difficult to share what you want to share. The web is also accessible. So kind of in the same way that we spend a lot of time preparing PDF documents and making sure that they're accessible before we upload them onto the Water Board's website. When we publish web content online, that also has to be accessible. And I'm not talking just about the visual aspects of things, so like font size and color contrast and all of those things that you're probably familiar with. But the accessibility guidelines also reach into the code itself. So how you structure a website, what roles you assign to different elements that live on that website, all of that has accessibility guidelines. So for the developer, it's a little bit more work, especially if you learned web development before those accessibility guidelines came out. But it really speaks to the open nature of the web and kind of creating meaningful access and just effective communication with everyone, including those with disabilities. And then the last one, the low barrier to entry. And that just refers to, it's very easy to create a website. Anyone can really get something out there. And as long as your website isn't like huge in size, or it has a lot of traffic, or you have like an additional server with all this data floating around, you can pretty much get by with free hosting. And not only that, you're not tied to a single platform. You can move around a lot, and you might use AWS, you might use Netlify, you might use GitHub Pages. There are a lot of options available for you. So no matter if you're a huge website like Amazon, or if you're just a developer starting out, you're all using the same platform. And the web is really a great way to reach other people and to reach a global audience. Let me see if I can. Okay. So what is web development? Web development really refers to the process of developing a website or developing a web application for the internet, or for a private network like an intranet. And it's actually a pretty big field in tech. There are a lot of specializations, but for this presentation, I'm going to simplify it into two specializations, and that's the front end and then the back end. So a front-end developer is really kind of concerned with everything that the user sees when they load a website. So they might use HTML, which is hypertext markup language, that really defines the structure of the website, and it gives it kind of good bones. And then you have CSS, cascading style sheets, that just adds style to your website. So that might be font, it might be colors, it might be spacing, but it's also really important in defining how content looks like when you have different screen sizes. So it's often used for creating responsive layouts that work on mobile devices just as well as they work on desktop devices. So again, going back to that cross-platform functionality. And then front-end developers also they have to use JavaScript. Like it's a really important language. It's a programming language, and it's used to implement interaction and dynamic content on a website. So basically, any type of interaction that you see going on in a website, like whether it's adding something to your shopping cart, or usually like clicking something and a pop-up comes up, that's JavaScript. It's really what kind of makes the site come alive. And then because front-end development is concerned with the visual aspects of website creation, front-end developers are usually the ones implementing the accessibility guidelines or the requirements. And they're also the ones really concerned about any user interface design and experience. Now, on the other end, the back end, you have the back-end developer who also does a lot of coding, but they do a lot of coding on the server. Back-end developers are, they work on everything that you don't see when you visit a website. So it's all about servers, it's all about databases. They're usually the ones building and maintaining the system architecture so that the application has a scalable backend, a very secure backend. And a lot of backend developers, they also they build APIs, which are application program interfaces. And these, I think some of you have used it before, but they're very useful for pulling data from another source. So a backend developer can actually develop APIs and use them either for internal use or make it available to the public. So for this presentation, I'm going to focus mostly on front-end development. And hopefully that makes sense because a lot of data visualization is mostly visual. It's what the user sees when they go onto a website. There is definitely some connection to the backend, especially because data visualizations are so reliant on all the data coming in. And servers and databases are the ones kind of feeding that data. But for this presentation, we're talking more about just kind of constructing the visual elements. So I'm going to focus more on the front end side of things. Okay, and then I wanted to talk a little bit too about the difference between data science and web development. Data science, I think a lot of you know, is kind of a multidisciplinary field that involves combining kind of this area expertise with mathematics, statistics, computer science, all of those things. And typically, you know, there's a lot of work involved in processing data and preparing it in order to use it for some type of, you know, analytics or modeling or maybe like machine learning. Web development, on the other hand, is web developers, they work a lot with data, especially now since a lot of websites are so data driven. But the main purpose of web development is really just to construct the website, to make a fast and accessible website. So web developer isn't necessarily doing all the analytics and all the machine learning things that a data scientist might do, unless they're building a machine learning web application, then they might have to get into that a little bit more. So they are two very separate fields. But I think in recent years, we've been seeing a lot of overlap, growing overlap between the two fields. And this kind of area, this overlap area, I think a lot can fit in that. But I think the main overlap is in data visualization and in creating user interfaces for those visualizations. I see a lot of data scientists today learning a lot of web development. They're learning JavaScript. They're learning a lot of JavaScript data visualization libraries. And likewise, I'm seeing a lot of web developers using a lot of the same tools that data scientists use. And again, going back to that whole idea that modern websites today are really data driven. There is so much data getting pumped in and out of these websites. So you're seeing a bit of convergence there. I still think they're two very different fields, but there's definitely overlap and a lot of potential for sharing ideas and sharing tools. Okay, so now I want to talk a little bit about, so JavaScript is the main programming language if you were to get into web development. You pretty much have to learn that if you want to do kind of a more complex web development, I think. And the same is true with data visualization. So a lot of the data visualization libraries using JavaScript, there are actually so many. And I swear, like, I think a new one comes up every month or so. But there's a reason for that. It's because JavaScript is the only programming language that actually runs natively in the browser. So it's the programming language that can actually start manipulating all of those low-level HTML elements, SVG, all those visual components, and basically turn them into a really nice data visualization. So as I mentioned, there are a ton of JavaScript charting libraries. It's if you're looking for a new one, it's almost like going shopping because there are just so many options and they all kind of differ slightly. But I think you can categorize them into two categories. So you have high-level charting libraries or data visualization libraries, and then you also have low-level ones. And high-level data visualization libraries, they have a high level of abstraction. And abstraction just means that you're hiding away or filtering away detail that is kind of unnecessary. So you're filtering all that away in order to focus on the things that, you know, mean something to you. And one of the best examples of abstraction is a car. you don't need to know how a car works in order to be able to drive it. You don't need to know how, like, what the parts do. You don't need to know like how all the parts interact. All of that is abstracted by a very simple interface that includes a steering wheel and then pedals, right? So when I go to the grocery store, I don't need to necessarily know how everything works. I just kind of get in the car and I just go, right? So the same thing kind of applies to these high-level data visualization libraries. They're highly abstracted, and usually that means they provide some type of template that you use, and you feed data into that template, and you might give it some options so that you can customize it a little bit. But that's it for the most part. You just kind of feed it what it needs, and then it'll pop out a data visualization. So of course, the good thing about high-level libraries are that they're very easy to use, but at the same time, they're less customizable. So if there's something that you want to change about that template and that library doesn't allow you to change it, then you're kind of out of luck, unless you really want to get messy. Now, low-level libraries, on the other hand, they operate close to the hardware, as they call it. And this just means that they're able to kind of directly manipulate those low-level visual elements like HTML. And in contrast to high-level libraries, they don't really offer like templates that you use. It's more like they might provide some tools to make some tasks a little bit easier. But for the most part, you're kind of on your own. You need to actually start building things from the ground up. The pros to this is that it's a very flexible and customizable because you have access to that very kind of to that very kind of fine-grained detail. But the cons to that is that it can be very difficult to learn because you have to know how everything works together. And it can also be very time-consuming to actually have to build it up layer by layer. That kind of figure on the right, I kind of blew it up here, but I'm not going to go into too much detail, but it just kind of visually shows you what I was talking about how there's kind of an inverse relationship between the level of abstraction and then the development time that may be required. So generally speaking, a high-level library is going to require less development time because it's super easy to just plug stuff in. But this diagram is also great because it shows the dependencies too, where you see a lot of high-level libraries are actually built on top of low-level libraries. And also a lot of other programming languages are often built on top of JavaScript, which is kind of more low level. But okay, so I prepared some code examples because number one, I want to show you the difference between kind of a high level and a low level library. And then I also want to just give you a peek at kind of the JavaScript code that's running behind it. And for this example, I used HighCharts, which is a high-level JavaScript library. And you can use it to create these really nice interactive data visualizations. And for this example, I created just this really simple time series chart. It doesn't, very simple stuff. It just has a little bit of interactivity with the tooltip that just gives you a little bit of information about each data point. But let me kind of show the code. So the code behind a high-level library like this is that generally the library will provide you the functions that you need to use. And you call these functions and you pass it a set of options that basically configure what the chart is going to look like. You might need to define some things like, for example, what the scales are based on. But for the most part, it's it's not a lot of coding. You're just kind of listing things, options that are defined usually in the documentation and defined in the library, and then you just pass it in. High charts has a kind of this weird syntax where they put a lot of objects within objects, so you kind of have a lot of white space everywhere. But for the most part, as you can see, it's just passing in a lot of options, telling high charts what you want, picking the closest template that'll look like kind of close to what you want it to look like, and then feeding in the data right here. The most programming is probably seen in this tooltip, configuring what's being shown in this tooltip window. But again, that's really super easy. And then once you run the function, pretty much this thing just spits out. It's there and it's ready to use. And you can either customize it a little further or put it in your application and publish it somewhere. So that's super easy, high level charting library. So I want to compare that now to a low level data visualization library using JavaScript. And one of the low level libraries, a very popular one, is called D3, which stands for Data Driven Documents. And I basically I created the same chart that I did in the last slide. It looks pretty much the same, maybe just some slight differences, but it has the exact same interactivity with the tooltip right there. And then I want to show you the differences in the code and exactly how you're building this up compared to a high level library. So number one, you have to start using JavaScript. You still pick the same things, like you need to define how large or how big your chart's going to be. You're pulling in data, but you have to actually initialize these low-level elements. So we're using SVG here. We have to start appending SVG to the canvas space, to the web page. You have to define exactly where it's going to be. You have to initialize the tooltip. All of this is just initializing things. And then you have to actually create the scales yourself. D3 provides some tools to make it a little bit easier to do that. But you still have to feed in the domain and range that you're using for both the X scale and the Y scale. So we're about 40 lines down right now, and we still haven't gotten to the part where we're actually drawing anything on the screen. So you also have to create the axes yourself, and then you feed in the scales that you just created above. And then it's only to this line right here where it starts to draw both the x-axis and the y-axis, as well as the labels that come with it. And so as you can see, there's a lot more involvement in terms of actually specifying exactly what this chart is going to look like and what units you're using, all those things. It's very involved. And then we get to the point where we're actually drawing the points. And not only do you have to define all the characteristics, the attributes, but you have to actually tell D3 exactly where it's going to go on the grid that you just created. So here's kind of the X and the Y coordinates for the charting grid. And then you also have to create the function, the interactivity too. You have to manually do all this stuff. So it's a lot of work, and I even have helper functions down here to help me with the positioning of the tooltip. So as you can see, it's totally different, just the way that it operates, the way that you interact with it, the level at which you interact with each of these elements. It's almost twice as many lines as well, but these are much kind of meatier lines. It's not just white space. So a huge difference there, a lot more involvement and a lot more work for these low-level libraries. So after seeing that, you're probably wondering, like, why in the world would anyone want to give themselves more work like that? Like, why, if you can create the same chart using a high-level library like high charts, and then using a low-level library like D3, why wouldn't you always just use high charts all the time? And that's a great question, because I do believe that for the majority of use cases, high-level libraries like that are going to, fit your needs. It's going to do what you want it to do. And unless you've got something else in mind that's a little different, I would say, yeah, go ahead and just use those high-level libraries. But there are cases in which using a low-level library like D3 is either necessary or it's preferable. And I just kind of briefly outlined some of those use cases here. And I think the first one is pretty obvious. If you have, or if you want to create a unique and highly customized visualization, chances are you're going to have to use a low-level library like D3. These type of things that you can't, oops, sorry. These type of things that you can't get from, a template or from something that's out of the box, you're going to have to start tinkering around using kind of that very detailed low-level kind of library. And then the second use case is if it's kind of similar, it's related. If you have any type of non-standard interactivity that's going on in your data visualization. So a lot of us are familiar with, when we're playing around with interactive data visualizations, filtering is a very standard type of interaction, sorting things, maybe clicking on a point and something else kind of pops up to the side. All of that is pretty standard. When you're thinking about doing like other stuff that's kind of outside the box of that, then you're definitely going to have to look at something like D3. And you can definitely build almost anything that you can imagine. But the problem is you have to build that from the ground up. So it's going to take a long time. But depending on what your project is and what your goals are, it may well be that the effort might be well worth it. And then the third use case is kind of related as well, but I think it's really important. I think it's actually the reason why a lot of people choose to use D3 and other low-level libraries, and then also JavaScript in general. But these low-level libraries are really good for adding interaction between the visualization and the user interface. So typically when you do create a data visualization, often you create a user interface as well, because that's how the user interacts with the data visualization and uses the controls that change the view of that data visualization. When you program your data visualization in JavaScript and you also program your user interface in that same language, those low-level elements can start to communicate with each other in a way that's not possible if you were to use a high-level library. So in that way, you can actually extend the functionality of the data visualization into other parts of the website that you wouldn't be able to do to otherwise. And this is really powerful. I don't have, unfortunately, I don't have any really good examples to show you today, but it's actually, I would say, number 1 and number 3 are probably the top reasons why people use it. And then the fourth one is for anything that really requires high performance. So if you're working with a very large data set, or if you're trying to render, a lot of graphics on your website, if you use kind of the typical ways of doing that, you're going to run into a limit very, very quickly. And the browser actually has, a very limited amount of memory. So it will start becoming very sluggish and very slow, and it might even crash. So when you're looking for high performance, either for rendering or for just, doing other maybe visual kind of interactions, you might need to go down to kind of the low level, kind of closer to the metal, in order to kind of squeeze out every drop of performance. And there are actually web technologies that are really optimized for doing just that. But the main way of interacting with them is through these kind of low level libraries. So next, I want to show you a couple of examples of some visualizations that I've created myself, and then also some that are available online that other people have created. And I just want to show some examples of kind of those 4 points that I just talked about, why somebody might want to use a low-level library versus a high-level library. And this first example is the Safe to Swim map, which I've been working on for a couple of years now. It's an interactive map, and it's a data viewer for viewing fecal indicator bacteria data at inland and coastal beach monitoring sites throughout the state. So I'll go ahead and open that right now. And you can see it's a very simple map. The interface is actually not that complicated. It's very typical for a lot of interactive maps. But if I go ahead and choose a site, so let me search for Discovery, this one. And if I go ahead and click this site, so it brings up a chart with the data that's specific for this site. And the chart itself is not too complicated. It's very similar to that time series chart that I showed you before. It just kind of graphs some extra elements. You have the sample results, as well as a 6-week geomean represented by those orange triangles. There are a lot of controls, as you can see. You can kind of switch between the different analytes. You can change the scale of the graph. I had originally started with linear, and then I changed it and gave it an option for the log scale. You can do some very standard stuff like just filtering things. And then there's like a timeline at the bottom where you can change how much data is being viewed in kind of this immediate chart up here. And I want to talk a little bit about the tech, because this isn't really a complicated or a complex chart, really. But the reason why I chose to use a low-level library like D3 was because there's one custom thing, like just one thing that I was like, oh, you know, I think it's actually going to be easier to do it in D3 compared to a lot of high-level libraries. And that custom thing are these geomean points. So let me kind of change the view a bit. So the orange triangles represent the rolling 6-week geomean. And I knew even before I created this application that I wanted those points, if you were to like hover over them, I wanted to be able to visually show that 6-week period on which those geomean calculations are being made. And that's actually not a standard thing that you can find in a lot of data visualizations, at least back then when I was looking into it. And that alone was kind of what made me choose to use D3 instead. Of course, there's always the chance that in the future, you know, I always anticipate that there will always be requests to make it even more custom than it is. So I like to leave a lot of flexibility there, a lot of kind of room for the data visualization to grow if it ever needs to. But my point with this is that you can create very simple data visualizations using low-level libraries, and then add kind of these custom flourishes. Some of the data visualizations that I show you later on are going to be really fancy, and they're going to have like crazy interaction, and it's going to be really cool. But I still wanted to show this because, first of all, I think this is a little bit closer to some of our use cases here at the water boards. And also because I do think that it is important to keep things simple at the same time. You don't want to add too much interaction, too much craziness just for the sake of doing that. So I wanted to provide just a kind of a more simple example here. But let me go ahead and show you the other examples, because I think they give you a bit more flavor in terms of what JavaScript is capable of. So this is a data visualization that was created by the New York Times in 2012. So it's a bit of an older one, but they created it to show kind of the details of Obama's 2013 budget proposal. And let me go ahead and switch that. I preloaded everything because I was nervous that with the New York Times, I might run into the paywall. But as you can see, actually, let me kind of start. Okay, so as you can see, this is it looks pretty simple, this data visualization, but there's actually a lot of interaction going on with how things are clustered. And there's some standard interaction where you can kind of see, the budget allocation, exactly how much money is going where. This is just kind of a great overview of what things look like. But with this data visualization, you can actually change the view of all of these points and start to kind of reorganize things based on different categories or whatnot. So right now we're kind of breaking that visualization apart. We're looking at how things are organized now by either whether it's mandatory spending or discretionary spending. If you notice that transition between the two views, none of the points actually went away. They stayed on the screen and they just kind of rearranged themselves. You can also change it right here to show the percent change from the previous year. So looking at, how much certain, maybe departments, the difference that they got compared to the previous year. Again, pretty standard interaction, but very nicely designed and very true to kind of the nature of this library that was being used. And then finally, the last view kind of sorts everything based on the department and, kind of adds everything up based on department and then sorts it based on which departments receive the most allocation and which receive the least. And again, I wanted to show that kind of transition and see that if you notice, nothing really leaves the page. You have some things that kind of become hidden, but everything kind of stays in this canvas. And that was kind of going back to what I was talking about with that kind of really tightly integrated, tight integration between the data elements and then the user interface. This isn't really a fancy user interface, but they respond based on what's being used. And they actually kind of hide and go away and rearrange themselves based on what's going on. This data visualization was created using D3. And D3 offers a lot of flexibility in terms of not only being able to do these type of interactions like that, but just in terms of like just binding data and actually like, and kind of moving things around and regrouping and all that stuff. It's pretty cool. The next data visualization I wanted to show is a map called the Highway Safety in the US. And it was created by a WebGL library. WebGL is actually a low-level web technology that is used to render 2D and 3D graphics on the web. And what's really cool about this data visualization is that it shows a lot of data. So we're looking at about 126,000 paths, so those line features, and then a total of about 405,000 vertices. And if you actually start zooming in, you'll notice that there's no hit to performance. It is smooth. And not only that, but it actually also preserves the kind of the attributes unique to every one of these line features. So you can see like the number of accidents with each one of these line features. But the fact that, for people who do mapping, this is actually pretty crazy. It actually kind of still blows my mind because it's always been traditionally very difficult to map these many, vector features on a single map and to have this kind of performance. But this library in particular is, it's actually, I consider it more of a high level library, but it works on very low level web technology. WebGL is very good at rendering lots and lots of features, lots and lots of graphics. And so you're starting to see a lot of data visualization specialists moving and trying to take advantage of technologies like WebGL. And then the last example that I have is this is actually a data visualization that I saw a long time ago, and it's kind of stuck with me ever since. And it's called the Dawn Wall, and it was created by the New York Times in 2015. And it was basically made to visualize. So in 2015, Tommy Caldwell and Kevin Jorgensen, they free climbed the Dawn Wall of El Capitan. And the New York Times documented all of this. And they created this really impressive data visualization that shows exactly their climbing route, and then has annotations of things of interest, like where their base camp was, areas where they had difficulty in it. It took them some time to get past it. And all of this is really interactive. So this is kind of the scrolly telling format, where you kind of scroll down and the visualization changes based on where you are in that scrolling kind of area. But you can see it's pretty crazy. You're basically kind of like flying up and down the wall, but it's nice because it provides that immersive experience. It provides a lot of context in terms of what you're seeing on the screen. And it's very unique. This is very custom. You're not going to find it in like a high-level library like HighCharts or something like that. But I wanted to talk about the tech behind this as well. So this data visualization, they actually use D3, which is a low-level library, and they also use 3JS, which is a low-level library for WebGL. So it's essentially combining those two technologies used in the last two examples that I showed you. So two very low-level libraries, combining them to make something really custom like this. And as you can see, it's very performant. It's very tightly integrated with the user interface. And it's really cool and memorable. I still remember it after all these years. Okay, so thanks for sitting through all those examples. It was kind of fun to show. But I want to talk about, so I think a lot of us can agree that you don't necessarily need to do all that crazy stuff, especially for our use cases here at the water boards. A lot of that low-level stuff that I just showed you is kind of overkill, right? Like we're not going to, like, who's going to build a 3D model of the Dawn Wall and have it like fly up and down? Like most of us are not going to do that. But what I really like about web development and JavaScript and everything kind of in that data science realm is having those options available. Web development is a very quickly moving field. There's constantly so many things coming up, new things to try, things that are kind of dying off. WebGL is one of them. I'm seeing just a lot of activity in that area. So having all these new kind of innovations, new libraries coming up, and having the option to even provide a little custom flourish, in my opinion, is, at least I like that way of development. I like having a lot of options. I like having a full toolbox that I can kind of pick and choose what I want to use. But I completely agree that for the most part, we're probably not going to use all of that and create some of those really kind of amazing data visualizations that, the New York Times has created. But I want to say that, the purpose of this presentation, I didn't want to like make this in order to try to convince you that, you need to learn JavaScript, you need to learn web development. That really wasn't the purpose of this. I just wanted to kind of introduce the technology behind everything, and then also give you a sense of what the capabilities are, the limitations, so that you can kind of make a determination for yourself whether this is something that you might look into in the future, or if it's completely not of your interest, and if it was your choice, you would never write a line of JavaScript. But I think it's really important to at least know that the technology exists. And I also want to say that I know that there are quite a lot of people who program at the water boards, and they already know a programming language really well. And if that programming language really kind of fits your needs and does everything that you want it to do, then definitely keep using that. It takes a lot of time and effort to learn a new programming language, to learn new technology. And I think you need a really good reason to have to kind of sink in all that time and that effort into learning something new. I personally started learning JavaScript when I had been using Python for several years. And Python is a great programming language. I still use it today. But one thing I didn't like about it was I just didn't like, I wasn't too fond of the way that you could publish things online. And I thought it was a bit cumbersome and a bit clunky. And JavaScript was something that just kept coming up. And I eventually just caved and decided to learn it, which I'm really happy about because it actually, I think it fits my style and the fact that I like to work with those low-level visual elements a little bit better. But I encourage you, especially if you know a programming language already, stick with that programming language if it works with you, and exhaust all of your options there before looking towards something else. I did compile kind of a list of data visualization libraries that are used in other programming languages that are actually built on top of D3 and other kind of low-level JavaScript libraries. So you might be able to use something like this if you haven't already to kind of extend the functionality so you get something similar to what D3 and other low-level libraries offer. But I just wanted to say that I do really like JavaScript. I really appreciate it because everything that you see that's a visual on a web page, all of it has to eventually be compiled to JavaScript in the end, because JavaScript is the only programming language that can be run natively in the browser. Okay. But at the same time, I also want to say that if you sat through this entire presentation and some of this really kind of spoke to you and you're interested in learning more, I've compiled kind of a short list of resources that I recommend for getting started. I also have just one tip as well, which is that if you're kind of brand new to web development and you decide you want to learn it, I recommend that you stick to these core web technologies here: HTML, CSS, JavaScript. Learn those things really well at first. Those are kind of the fundamentals. Web development is kind of crazy. There's so much stuff going on, and it's easy to get distracted by the latest and greatest framework or the latest and greatest library. But to really kind of be able to manipulate things on that low level, you have to know the basics really well. So I think it's really worthwhile to spend a lot of time on that, and then you can jump into the exciting frameworks and libraries and whatnot. But I'll go ahead and end it here. Thank you so much for sitting through my presentation and for listening to something that I really enjoy and that I really like. The link to my slides are in the middle of that page right there. Also, feel free to contact me anytime if you have any questions or if you just want to connect. Especially, I'd love to connect too. If you already work with a lot of these web technologies, it'd be great to be able to talk and throw ideas around. So that's all I have. And thank you again. And I'm happy to take any questions that you might have.
Great, thanks, Michelle. I wanted to, we do have a couple questions. I wanted to see if either one of the the people that had submitted questions to QA wanted to raise their hand and give it verbally, or if they'd prefer I read it to Michelle and have her respond verbally. Either Anna or Patrick. Anna would. All right. You should be able to talk.
Hi, Michelle. That was
Hey,
an
Anna.
awesome presentation. Thank you so much. One of the things that I was thinking about when you were talking about all this is it seems like in order to implement the web development techniques that you were talking about, as a water board staff, we might have to have access to like an authority and permission to update web pages, which we generally have to go through the DIT web request process to do that. So I was just wondering if you could kind of give us some examples of how you are implementing these sort of web development types of skills and libraries overlaid with like the visualization piece without having to go through DIT, or is that part of your process, if that makes sense?
Yeah, no, that makes sense. And that's a really great question. So I kind of mentioned before that there is quite a bit of flexibility in terms of where you can host your website. And one of those options for sure is that, the water boards, we do have a website, we have a web server. That's how we serve our webpage to the public. And you can actually host on the water board's website. That's something that I've done in the past. And the cool thing about it is you do get like an official water board's URL. So it's very official. But it's true that, anytime you make an update to something that's hosted on our official water board's website, you have to send a request to our DIT web support. And I think I had to do that both when I uploaded the initial files and then also for sending updated files. And I sent a standard web request for most of it. I think you do have to probably double check that, that you're meeting kind of the requirements of DIT before you do that. The web support staff are really helpful, and they'll actually sometimes alert you to something that you might have missed or whatnot before they publish it. But for sure, if you go that route, if you publish something on the water board's website, I don't think that's something you can really avoid, because our web server is maintained by DIT staff, and it is much better to kind of follow that kind of workflow of submitting a request. Now, you don't have to necessarily host your website on the water board's website. So I actually host a lot of like, especially my prototypes and everything, on GitHub pages. I'll also host it on some of those free hosting platforms, which they're pretty much free as long as your websites, aren't like really big. So I use Netlify, I use GitHub pages. There's also a way to like use AWS if you have access to that. And those are actually really, really easy ways to get your stuff online. The only downside, of course, is that you just don't get the official water board's URL, but it's a very simple process where you're in control of just everything. You just kind of, for GitHub pages, you just you push your work up to GitHub, and it kind of just automatically creates that page for you. Same thing with Netlify. So it just kind of depends where you want to kind of put your page and some of the trade-offs. But if you're looking to publish on the water board's website with a URL, that will definitely, you have to go through DIT for that, because as staff, we don't, as non-DIT staff, we don't have any control over it. Did that answer your question? I kind of went on too.
I think that was great, Michelle.
Okay.
Before we run out of time, I want to get to the second question. Patrick asks, the Safe to Swim app seems to call on a lot of data. How are you able to maintain performance?
Yeah, so great question. So the Safe to Swim app is using third-party APIs. So everything about that, so there's no internal server that we're using here on the water boards. Everything is served up through the web server, the front end client. And any data calls are actually using the Open Data Portal API. So I have several resources on there, which it's pulling from directly. And that makes it really easy because I can control when exactly all the data is being pulled in. Usually it doesn't make an API call until you actually click on a site. So that kind of help controls you're not pulling in too much data at once. And then the same thing with the map. When the map initializes, it just makes one API call. So that I think helps with the performance a little bit. The fact that there are some sites that have a lot more data points than others. I'm using D3 instead. There's an option in D3 where instead of using SVG, which can really kind of slow down if you have a lot of data points, it's doing a fallback and using Canvas. So I think the same is true with the map as well. So.
Thanks, Michelle. There was a third question that was related to accessibility standards, which I answered in text, but since we have 1 minute of time, it was from Brian Taylor. He said, assuming this is for public consumption, does it have to conform to web accessibility standards?
Yeah, so good question. So I definitely can't claim to be an accessibility standards expert. I do know quite a bit on how to how to do it in the code. But yeah, my understanding is that it is kind of required. And especially for publishing on the water board's website itself. I think there's definitely a big requirement there. I think there's a little bit of leeway in that, especially for interactive data visualizations, you can't make everything 100% accessible. But JavaScript and HTML and the web technologies, you can make it more accessible than, you can kind of work at a lower level and make it more accessible than it would be maybe using other tools. But yeah, I think for a lot of web developers today, it's pretty much assumed that you have to, it's required, and you need to make it as accessible as possible.
Great. Yeah, that's basically what I said. I said basically, they do apply, but because they're intended to be visual in nature, they're a little bit different. And a lot of these, the visualization programs themselves are working on it. And then I know that for the Waterboard's web pages, DIT uses a third-party service called AudioEye for accessibility standards for like the web pages and the stuff being visualized there too. But the main things to be careful of with visualizations is color for color blindness and having a good textual description. So I provided all that in the written response. But
yes,
I just want to say awesome presentation, Michelle. Thanks so much.
Yeah, thank you.
It was really interesting, and please, if you want to reach out if some other questions pop up, please feel free to reach out to Michelle directly. And thanks again. Have a great rest of your day and your week.
All right. Thank you, everyone.